2. I think we jump in. Hello and welcome to today's session with BB Dev Days. We are going to be speaking with Jorge Cao of Florida International University on predicting future write-offs. Thank you for joining us.
Thank you, Brenda. Let me share my screen. Well, good afternoon, everybody. So happy to be here to share with you this work we did predicting future write-off using machine learning. I'm going to structure the presentation, having a brief introduction to the problem, the need behind, how can machine learning help in these scenarios and problems, what data do we use, the impact of the model in practice, how we use it, or the business department use it once we're done. And summary at the end to understand better all the details touched during the presentation. And Q&A session at the end to answer any question you have or go deeper into any detail. As all we know, organizations, especially those involved in fundraising, nonprofits, rely on donations, often in form of pledges. However, unlike explicit donations like cash, giving kinds, and all those direct donations, pledges don't come with a guarantee of fulfillment. Unfortunately, this can lead to situations where pledges are not honored in the end, causing what we call write-offs that could be partial or could be for the entire amount of the pledge. And that creates a real financial instability that we want to avoid. Predicting this write-off early will have a huge impact for us, helping us engage proactively with the donors and securing a more reliable financial support from this type of donations. From then, the main goal of our work was identifying early those pledging risk. We have two main elements in our solution. One was machine learning. We created a machine learning model that learned from data from closed pledges and learn how to predict potential risks on write-off and open pledges. And the other part was the strategic data. We built a variety of biographical, giving behavior, pledge characteristics, and interaction-related constructed data points. We're gonna talk about in a few. How can machine learning help? Let's start saying machine learning is a subset of artificial intelligence with a huge relation with data science. In machine learning, we create a model which we train with data. Train is the term of the learning process of the model. And the model learned to perform a certain AI task. In this case, binary classification, because in the end, we're going to pass this open and actual pledges we have in the system. And the model will classify in binary 0, 1 in case of risky or not risky pledges. This is more or less the workflow at the end. We have an input data with the open pledges that we pass through the model. And then we have the output data that is the classification of those pledges into risky or not, of having future write-offs. You can probably ask why machine learning is suited here, or maybe we can go with like a simple solution. The complexity and the volume of historical data having in these cases thousands, tens, hundreds of thousands, sometimes of rows and a various set of column features, as we call it on machine learning, make it impossible for us to detect like important patterns or make conclusions from that huge amount of just numbers and words. Here is where these models, machines, excels, models can analyze and process this data so much faster and reliable. And once the model is done, provide consistently accurate predictions. In our case, we started with 4 models, well suited for the type of data, the characteristics of the data, and the AI tasks we need to perform. That it was binary classification, as I mentioned before. On the final call, we end up with 2, XGBoost and LightGVM. This is kind of a general knowledge to explain you more or less about the models. XGBoost and LightGVM are 2 ensemble decision tree methods. Basically, the difference between these 2 is that XGBoost use a deep-wise way to construct the tree, and LightGVM use a leaf-wise uh, um, architecture to build a tree of the solution. Why try several more? This is a common practice in machine learning. We look at the data and we try to look for several models that are suited for the data, suited for the type of solution, the AI task that we are trying to get from the model. And then that allows you to compare the models and find kind of a balance between several elements of any model that are important, like the speed, the performance metrics, the flexibility that offer the hyperparameters, and the complexity of the model by itself, giving to the final solution a most robust model. What data do we use? We use, I build 2 main blocks of the data, of the features that we get from our system to train and to fit the model. One was related to the pledge by itself. From there, we get the year out of the day, the month out of the day as well, as a separated features, the amount of the pledge, of course, the write-off flag that you can see it on yellow because this is the kind of the key element. This is a binary column where we have just the flag to see if the pledge had or not a write-off. The destination, that is basically the school or unit where the pledge went, and I'm not using it just explicitly as that. I'm using it kind of an indicator comparing with the grants from the donor to kind of provide the model with some affinity, because it's basically trying to provide the model with as much resources as possible. And then I wanted to have this detail about the destination and then the grant of the model to kind of measure that as well. And the yearly pace is the last one from the pledge. That is basically probably the most of the pledges has have an a schedule that is most of the time for years to pay. Then this is basically measuring how much of the amount of the pledge is scheduled to pay in a yearly basis. From the donor, we have the solicitation acceptance rate. This is basically the solicitation accepted versus decline before making the pledge, just to kind of measure more or less or give resources to the model of the interaction in solicitation wise of the donor and the institution. The previous giving power versus the pledge amount, also to provide kind of insights into what was the real power, giving power of the donor before making the pledge, and how that compare with the real amount of the pledge to give resources to the model to see if maybe the pledge was too high or something like that. This is kind of an indicator to see if during the life of the pledge, the donor had an assigned manager change. The interaction during pledge, or basically during the pledge, how many interactions were between the donor and the institution to kind of measure or give information about the stewardship process during the pledge. And the time being a donor, this basically the donor age before making the pledge. Basically, the time between the first gift and the moment of making that pledge. How we use the model in practice, we had immediate operational benefits because that early identification allow us to implement tailored donor engagement strategies, from personalized communications, early follow-ups, pledge reminder, custom pledge reminders, increases stewardship, and also labeling those pledges in the system will allow all the parties involved in the stewardship process, from the current assigned manager, all the development officers, the business departments, everybody being aware of the potential risk detected. The other part is the application of SAI. SAI is explainable AI. Explainable AI is a group of techniques or methods used to get additional insight and provide interpretability out of AI solutions. Most of the models are abstract or black boxes in case of neural networks, deep neural networks that are even more abstract. But for example, like GVM, that it was the final model of our solution, you can see here kind of a graph of the final model. Once even seeing that it's a decision tree and you see the splitting, and probably you can say, hey, maybe I can see or take some conclusions out of this. Is really abstract because this is an ensemble method. This is several decision trees combined, and it's difficult to get something out of this for kind of a business department or non-technical people. From there, we the other part is that even seeing this, we don't have, beyond the output of the model, we don't have any extra information about how the model used the data in reality. Which of all those features related to the pledge or the donor, which of those have like a bigger influence in the decision-making process, have a bigger impact into the labeling of those pledges. And that is where we introduce feature importance. We use it for this problem. It's one of the most popular explainable AI techniques, and we use it looking for those insights that can probably bring extra information about the classification process. Here you can see a graph of the implementation, and you can see how the model is telling us that the pledge donor, seeing the age of the pledge, it was the most important feature into the decision-making process. The year of the pledge has a bigger impact, along with the previous giving power, the relationship between the previous giving power and the pledge amount, and the month of the pledge and the yearly pays to close the top 5 of the feature more relevant to the decision making process of the model. As a
Jorge,
summary,
can I introduce in 1 second? The slides aren't moving forward. Are you moving through the slideshow?
I'm sorry?
Are you transitioning the slides in the slideshow? We're still on the opening slide. There we go.
No.
Okay. Okay.
Can I go at the end or okay?
And for everyone that's on here, we'll show the presentation at the end as well.
They are seeing it now, or
I see the summary slide.
the summary is not?
It just says summary on it.
Yeah.
Is that where we should be?
Yeah. Because in the next, I have something dynamic to see.
Okay. Because it's not in presentation mode. Okay. You can continue and I'll keep working on it.
Yeah, let me. I think I lost the. I think I lost the control of the. Yeah, I know.
You can continue on. We'll share the slide presentation at the end and I'll work on it.
Okay, yeah. Well, as a summary, we had the closed pledges that were already closed, some of them having write-offs, some others not. According to the data and the AI tasks that we will need to perform, we choose a model that we feed with that data. We implemented all the data transformation needed. We train the model. We tune the hyperparameters. We do the testing of the model and measure the performance. From there, we got the final machine learning model. And then we use all the same data points from open pledges we have already open on the system, and we're gonna run those through the model to get the final the classification of this model of those pledges in risky or not risky. Later, we put these labels back on NXT, Prices X NXT, to allow everybody to be aware of these risky pledges, and also the study of the explainable AI to provide more interpretability and even sometimes business people can get conclusions about this and how we are doing our procedures, solicitations, preparations, etc. Thank you. Did you have any question or?
So I don't see any specific questions posted in chat, except that our issues with the slideshow not progressing, which I'm not seeing a way to fix that at the moment.
We never.
So we'll open this up to the floor for conversation or questions.
Okay, but they didn't see the presentation.
Some saw some of the slides. I can see the slides, but they couldn't see the full. Some of it didn't see any of it. Okay. I don't see anything else to change on here. Looking to see. Okay, our first question is, do constituents receive recognition for pledges? If so, what happens when a 12 installment is written off after, say, the third installment?
If you pay part of the pledge, basically that's a partial write-off, as we mentioned before. At the end, that pledge is marked as having a write-off, because even when it was not the full amount, people make a write-off, for a portion of what the commitment was at the beginning. I don't know exactly if they get recognition for pledges. Yeah. I don't know if they basically. I know they get give receipts and all that, but I'm not exactly sure of the recognition part.
It says we have an issue with this, so any input is helpful. I will say with the
Uh,
organizations that I work with, recognition tends to fall when the pledge is fulfilled. But it could be at any time.
hmm, is there a question on the chat? Is there?
Yeah, so they have an issue with this, so any input is helpful with the recognition piece.
Okay, I can just find out, but I'm not familiar working more on the technical side. But yes, we have donor relation had a recognition program. Obviously sending um, thanks to the donors every time they make a gift. We have I did a dashboard for tracking certain gift, certain criteria. Most of the criteria is related to the amount, to say thanks to the donors and recognize. We have several programs related to that. By installment or full pledge amount when all installment paid. I don't understand that part. Yeah, basically the pledges have installments. Um, they need to basically pay each installment to cover the entire pledge. The normal behavior when they have write off is something like that. Um, they miss some installments. They start having past due payments, and then most of the time write offs comes after that.
Any other questions? Technical questions about predicting write-offs? For me, I was speaking directly about donor recognition programs, reflecting which part of the pledge, the fulfillment of the pledge or the pledge amount.
Yeah, I'm not. I repeat,
Yes.
I'm not that familiar with the recognition programs. This is more the donor relation department, things like that. I just giving an answer from my knowledge, but I'm not familiar 100% with the actual programs we have. Basically, our idea is try to detect this purchasing risk as early as possible to try to implement custom, probably increases stewardship, follow-ups, etc. To don't get into the scenario of having past due installments and then and ending up with the write-offs in general. Kind of helping to keeping us aware of, following the path behavior of these pledges and projecting for the future ones.
Excellent. And Jim just mentioned that he's looking at AI as a possible way to identify orphaned recognition.
Yeah, basically with AI, machine learning, you can do so many things. At the end, basically, you need just to organize what data do you have, what kind of output do you need from the model, if it's a classification, if it's the different AI tasks that the model does. And of course, I'm pretty sure you can do it.
All right, we have a couple more minutes. We will make sure you get a copy of the presentation. We'll also be sending out the brief survey. Apologize for our technical difficulties. Are there any additional questions? All right, Jorge, thank you so much for your time and your expertise
Thank
sharing
you so
with us.
much.
We appreciate it.
Thank you. You want me to send the presentation by email to you?
I have Eric on the line. Eric?